So the program committee asked me to come and talk about 100 gig and especially what's going on in the developments and beyond 100 gig. And I started thinking about the topic, and it turns out that building routers is kind of complex. And if we really talked about everything that goes into the next interface speed and things like that, we could probably be here for a couple of days. So I tried to kind of break it down into three areas that we're going to, one that we're going to talk about, and then a couple that we aren't going to talk about. So what I'm going to talk about today is strictly the next interface technology speeds, what's going on with the 100 gig developments, what's coming beyond 100 gig, and then Drew Perkins is going to have a great talk tomorrow about what's going on in the optical world. So he's a really smart guy on optics, and that's not really my area of expertise. And then the one that we have to skip, but that's really a challenge as we design these higher speed interfaces, is the packet processing and the memory components and all the things that kind of sit behind the interface. So I did some calculations, and it turns out that at 100 gig, at 64-byte frames, that's a packet every 6.7 nanoseconds. So that's actually pushing component clock cycles to do those lookups. So that's interesting. And I was talking to some people at NANOG and over email, and it seems like that's a really interesting topic maybe for the next NANOG. We had a BOF at the Toronto NANOG where we talked about CAM and memory architectures, and it seems like that was really interesting. So I think it's time to talk about that kind of stuff again. So I showed this slide, I think, at the October NANOG where I was talking about the Ethernet developments. So this is just kind of for your reference because we do throw a lot of acronyms around and all these different standards organizations. So this is basically how they all fit together. The update that I made is I added a lot of the optical standards bodies because there is so much going on with the 100 gig optics that it's really important. So the current state of the industry is that the 100 gig standard has actually been out for almost a year. So it was done in June of last year. So it is a year now because we're in June. So basically, the industry has already demanded that there are interface speeds and different architectures that are outside the standard. That's okay. The standard is designed to be flexible, just like the 10 gig standard was, so that we can have a bunch of different interfaces as new technology develops that are still standard 40 and 100 gig. This is really the fundamental limitation, is that we're trying to do 100 gig with 10 and 25 gig technology. That's just the technology that we have available today, and that's also mass produced and available at costs that we can afford to build interfaces. The electrical signaling inside the router or on a line card is really challenging because the best we can do right now is to use a bunch of lanes of 10 gig to go into that optic. And then in terms of the optical signaling, the best technology that we have right now is either 10 lanes of 10 gig or 4 lanes of 25 gig. And then the CFP module, which is the module shown here, that's the 100 gig optics module, is actually quite large. From an interface, from a power and front panel density viewpoint, it's kind of a large module, which limits what we can do with it. So basically, the second generation 100 gig technology that we're working on is going to take a lot of complicated circuitry that we have on the back end that converts 10 gig into 25 gig off of the back of that module and basically allow us to go 25 gig into the optics module and then 25 gig lasers onto the fiber. So that'll really reduce a lot of the complexity, the cost. It'll save power and space and allow us to make smaller optics. So throughout this whole presentation, you're going to hear second generation 100 gig Ethernet uses 4x25 electrical and optical signaling. That's the gist of the technology and where we're going. If you look at front panel density trends, so we're in 2010 right now. The best we can do in terms of just fitting the optics onto the front panel right now is 4 ports 100 gig. So that's assuming, of course, that we have router capacity and switching capacity and that kind of stuff. I'm just talking strictly, if you look at the front of a line card, we can only fit 4 ports on there. Now the optics roadmaps that we have that take us into 2013 are going to give us a lot more density. So that'll allow us to at least double, probably triple and quadruple the density that we have available as we get into 2013 and beyond. And then the next speed, I have some slides in the back that I'll talk about it, but possibly we could have 2 ports of 400 gig several years from now. But really, if you just this is really just the challenge that we're working with, trying to fit all this stuff on the front of the board. So in terms of the initiatives, these are really the key things that are going on in 2011 that are going to build the technology for 2013 and possibly into 2014. And we'll kind of start at the bottom. If you think of this like an OSI or network layer model, the OIF has to develop electrical interfaces that the modules then use, so those build on top of that, and then the IEEE has to use those optic modules and standards to build the next generation speeds. So some of it is kind of low level, but I tried to make it as exciting as possible. Electrical signaling doesn't interest everyone, but it's kind of a fundamental building block, so we have to talk about it just a little bit. So what's going on is that the OIF is building new electrical signaling interfaces. So you remember I said that right now we're limited as far as the electrical signaling inside the box, we're limited to 10 gigs. So we have to use some sort of combination of 10 gig to build 100 gig interfaces, and 10 by 10 seems to make the math work out right. So what's happening is that they're developing this new standard which allows us to go to 25 gig electrical signaling. There's a couple different ones that are not so interesting. The one that we're really interested in is the third one, which is a 4-inch 25 gig standard interface, which will allow us to connect the optical modules directly to some ASIC or some component in the router. So this is what allows us to get rid of those 10 lanes of 10 gig and go to 4 lanes of 25 gig natively into the optics module without any modification. So in terms of new media modules, I thought it would be interesting to take a look at 10 gig. And if you look at the different generations of technology, some people, when I explain about 100 gig, they think that there's just a 100 gig interface that you plug into a router and it's all 100 gig, and they don't realize that there's a lot of multiplexing and reuse of lower speed technology on the back end. But I didn't realize this too. I thought it was very interesting that the first generation 10 gig module actually used 16 lanes of 644 megabits per second going into the module electrical signaling. So I think the 100 gig is going to follow the same roadmap in terms of generations of technology, where we go as fast as we can and then we develop something new, and that becomes the next generation. The other thing I like to point out is that the size of the modules also decreased very significantly, going from the original 300-pin MSA, which was actually a fixed optic modules, down to SFP plus in about 7 years. So the blue blobby squares represent the actually relative module dimensions. So you can see that SFP plus is, I don't know, maybe 10 or 15 times smaller than the original 300-pin MSA module. So we'll see the same thing with 100 gig. And if you look at the size of the CFP and then some of the proposed second generation modules, you can see that they're drastically smaller. And that goes back to the slide that I showed with the front panel density. That will allow us to put a lot more ports on the front of a line card or a switch or a 1U size rack device. The other thing that I want to point out is that really there's a new electrical interface. So right now we're using what's called GbE and GbE. They're kind of fun acronyms to say, so you can impress your friends at the next party or something. So right now those use 10 by 10 electrical signaling, and then the newer ones, which are called GbE 4 and GbE 4, are the second generation ones, which we use 4 by 25 electrical signaling. And then the roadmap is really 2013 plus, and I have some more slides that show how we're going to get there. So I think this is kind of an interesting comparison that just shows where we're going in terms of technology. Here's a different slide that shows you kind of in a more graphical form where the CFP MSA is going with front panel density. And then here's a really great diagram from Molex that actually shows a much better size comparison. So if you look at the CFP module that we have right now and where we're going with CFP2 and then the new QSFP, that just really illustrates the different form factors and how much more we'll be able to do with smaller media. This is just some really detailed block diagrams of how the current modules work. The point here again is that we're using 10 by 10 to go into 4 by 25. That adds cost and complexity and takes up space in the module and things like that. So again, the point is that we're going to native 4 by 25 electrical and optical. Okay. So in terms of what's going on with 100 gig, there have been some new copper projects which I don't think are that interesting for network operators. There's a new backplane specification that the IEEE is working on. They're also working on a new 100 gig over copper cable. So I haven't seen anyone actually deploy 100 gig over copper cable using the current interface specification. There just doesn't seem to be a lot of interest in the market, but I think in a couple years when we have servers that are pushing more than 10 gigs and they may need 100 gig interfaces several years in the future, I think that could be an interesting option. What we're really interested in terms of backbone networks and data center networks is what's going on with the 10 by 10 MSA. So I think I briefly talked about this in one of my previous presentations, but it's really great because the 10 by 10 MSA has several network operators that have joined the group and are participating and telling us exactly what they need and what they're thinking and where they're going with their data centers and networks. So AMZIX has joined, Facebook and Google have been long-term members that are really driving a lot of the cost requirements and density requirements as to what they need in their data centers. There's a couple new standards that they're finishing up. There's a 10 kilometer and a 40 kilometer standard, which should be done next month. And then they're also, this is an interesting kind of side project where they're looking at trying to mux a bunch of 100 gig waves onto one fiber to give us a lot higher capacity. So that work is still ongoing. I'm not sure when that's going to be done. And then in the IEEE, they're going to start a couple new projects next month, which will basically define those new interfaces that we use the optics that I showed you on the previous slide. So they have to define a couple new actual physical interfaces. Then they have to define those electrical signaling, COWI and KIPI4, which go into the new QSFP modules. And then if you remember the slide I showed you on front panel density and the previous slides in terms of the module form factors, we're going to be in a position where the industry is going to have possibly two competing optics, the QSFP and then the CFP 2 and 4, which will be competing for density. And what we don't want to happen is this thing that happened with 10 gig, where we actually had the XPAC and the X2, which were two competing standards, and then we had to make a choice in the industry. So we're trying to avoid that, but unfortunately, each standards organization has their own members and their own objectives, and we may be put in a position where we actually have two competing module standards. So if you put it all together, this is kind of what it looks like today. So with first generation, we have these 10 by 10 lanes going into the optical module. We can only fit 4 ports on a blade. Second generation will remove all that 10 by 10 signaling, allow us to do 4 by 25 electrical into the module, give us a lot smaller modules, so we get a lot higher port density. So this is a slide that I wrote a couple years specifically for Patrick Gilmore, and I was showing it at a conference and he fell asleep, so apparently the slide was really boring. So I hope this is more interesting because now we have some actual data on 100 gig projections. What I did is I took some Del Oro historical data and then some Infonetics projections on 10 gig and also 100 gig, historical data on gig, and if you look at it in a relative price, what's happened with 10 gig and gig Ethernet is that in the first several years, say the first 2 years, there's been a really significant cost decrease in the technology. And if you look at the projections for 100 gig that we have now, we see that same sort of decrease, which is roughly, I'd say, I don't know, 50 to 60% in the first couple years, and definitely as we move on into the third and fourth years, we see a really significant cost decrease. So I think everyone that's involved in either buying or selling 100 gig right now would agree that the prices aren't where we want them, but this is just where we are in the industry. And then especially if you think about the second generation, which is going to come in 2013, so it'd be around year, I guess that's year 4, that's where we really see the significant cost decrease. And the decrease from now until then is really just production volumes ramping up and manufacturers being able to optimize their pipeline and stuff like that. So last year, for example, I think the industry maybe sold a couple hundred modules. So that basically means that the optics manufacturers are almost building these things by hand. So there's no volume advantages that you get when you're building stuff by hand. So as production ramps up, the costs have already started to come down this year, and expect them to drop a lot more in the next couple of years. Here's my horribly dense technology summary slide. I don't expect you to be able to read this, but if you ever need to know a standard or what it uses, this is everything that we know about 100 gig right now today on one reference slide. So you can use that as a reference. And if we look at what's going on beyond 100 gig, so people want faster interfaces, and that's great. We agree. The industry needs faster interfaces. Unfortunately, we have these constraints. And I thought of this saying that we have in the industry that says all solutions are good, fast, or cheap, and pick any two. And that's really true with any problem in networking, I guess. But this is where we are, especially with higher speed interfaces. This diagram is actually from the IEEE. It was drawn in 2006 and then presented in 2007 on bandwidth projections. And I don't think it's that off. And then what I did is I extended this green line from the red line that was in the original graph about link capacity. And it turns out that we actually do need terabit link capacities fairly soon. Now, the short-term way that we can get there is using link aggregation with 100 gig. I think that's a pretty obvious solution. Lag has been tested for a number of years, and we know how it works, and that's a good solution. But in the future, we are going to need some sort of higher speed interface beyond what link aggregation can give us. And then I drew this slide to kind of show you all the things that we have to consider. And I put second generation technology and higher speeds on it, but it really applies to any interface technology. So we have to consider the technical feasibility, which is the form factor, which goes into power and cooling and things like that, the optical signaling, electrical signaling. And we have to balance that with what all you need in the market and what you're willing to pay for it. So if we build something that's really awesome but no one can afford, then there's really no point in doing that. Or if we build something that's really terrible and cheap, that's not really what you want either. So the point of this slide is really that we have to balance all the requirements with the economics of what we can do today, and hopefully that's something that people can afford. So in terms of what's going on with the next speed, this is a slide that's modified from one that I used to present all the time. But basically, if you look at where the standards went, it was 8 years between 10 gig and 100 gig, and that was a long time. Some people think it was too long. I think it was a little bit long. But the point of this slide is that if you look at the IEEE process and where we have to go to get higher speeds, we need to do something now in order to get something new by 2016. So what's going on right now is that there's what's called an ad hoc in the IEEE, and what they're doing really is they're laying the groundwork and investigating all the requirements for the next Ethernet speed. They're not going to make a decision. Their job really is to provide data and input into the IEEE to try and shorten that process. When we built 100 gig, we spent a lot of time in the early IEEE meetings talking about what do we even need. So the goal here is to get all that data up front so the IEEE process is a little more streamlined and goes a little faster. They have an open web page and a mailing list if you'd like to join that. And this is really the call for action for you, all the network operators, is that they really want your input. And they want your input on anything. It can be speed, network diagrams, traffic projections, cost requirements, density requirements, anything, media requirements, distance requirements, anything that you're considering when you're designing your future networks, they would like to hear. And they would like to take that data and hopefully build something that really matches all of our needs. You can get on a conference call, you can schedule something in person. It's really opportunistic, and they really want to talk to you. So that's about as simple as I can put it. There's a public request for data, which is a formal letter that you can read at this URL, or you can just send the chair email, and I'm sure he will get back to you very quickly. So, but please get involved and share your requirements. So in terms of what's going on in the future, right now I told you that the IEEE is really focused in the next couple years on the second generation of 100 gig. We'd like to go 100 gig serial. It's just not really technically feasible and economically feasible. So for the next couple years in the second generation, we're going to have this 4x25 to make 100 gig. Third generation 100 gig, I'd say we'll probably see some developments past 2015. 100 gig serial may be feasible then, but we just have to figure out what we can do in terms of the electrical signaling, and we'll get a better idea as we deploy more of the 25 gig CEI that I talked about. So the next higher speed Ethernet, there's been a lot of debate in the industry, and there have been several public conferences, and there was a light reading event a couple months ago or a couple weeks ago where one of the executives from Comcast made a very good presentation and said that they need terabit Ethernet now. So in terms of what we can do, we could do kind of boring things like 250 gig or 300 gig, but no one really wants that because we want a faster speed. Technically, the best candidate is actually 400 gig Ethernet. So if we can mux together 16 25 gig electrical lanes and optical lanes, we could actually build 400 gig fairly economically. And then that would also be an easy step into 40 gig signaling using 10 lanes. So we go from 25 lanes of, 16 lanes of 25 gig to 10 lanes of 40 gig. In the second generation, terabit Ethernet is just simply, it's impractical. So that's one of those things where, yeah, we could build it, but it would be just a, well, this is a technical term that one of our guys used. He said it would make a gigantic media module. So, you know, you can, I don't even know if we could fit it on the front panel of a line card, actually, because it would have so many lanes. And the 40 gig serial lanes just really aren't going to be economical until after 2016. There's I'm not an electrical engineer, but if you talk to these guys, they're really worried about all this loss and super high frequency signaling on the line cards between the components, and it's really complicated stuff. They're just really pushing the limits of that technology, so it's just impractical. Probably, my guess is that we'll see terabit Ethernet maybe in 2020, but we just can't build it economically with the technology that we have today. So here's a quick picture of what a 400 gig media module could look like. Obviously, you have to be a lot bigger than the current CFPs that we have. The 100 gig CFPs are actually slightly larger than an iPhone, so that kind of gives you an idea of how big the modules are. This would be even bigger, so we may be able to fit 2 ports on a line card, probably not more than 2 ports. So this is the summary. So first generation technology, as we said, uses all this 10 by 10 electrical signaling. We have relatively large CFP modules. Second generation of 100 gig is going to use the new modules and 4 by 25 electrical signaling. We're going to work on 100 gig second generation for the next couple years. If we get all the data that we need in the IEEE, we could start on a project for 400 gig that could probably be done by 2016. And then, as I mentioned, as much as everyone in the industry would like to do terabit Ethernet, it's just really impractical and unfeasible until a couple years from now when we have better technology. And that's it. Questions? Comments? Would anyone like to yell at me?
Nice to talk, Greg. Thanks. I'm just wondering, since you're saying terabit's really not technically feasible in the near term, but we have traffic growth that requires it,
yep.
How do you see that unfolding?
So I think it's going to be a challenge. So speaking with my Brocade hat on, we have some customers that are running more than 32 10 gig links in a lag, and they're very unhappy managing that many links, but we don't have any other choices. Until we get there, link aggregation really I think is the only choice that we have. Link aggregation and ECMP. So we expect people from the very get-go to deploy several hundred gig links in a lag, both for redundancy and capacity reasons. But other than that, I don't know, and that's a tough question.
Anything else? Okay, thank you.
Right.